So thank you all for joining, those in the live audience as well as those who are there in person. I'm Molly Presley. I'm the SVP of Marketing here at Hammerspace, and we're going to talk about a topic that is absolutely top of mind, I think, for most companies in the world right now, and that's how to make their remote workforces more productive. So at Hammerspace, we create a global data environment with our software, and the concept of that is to raise the value of data up above the storage system, not just to make it viewable, but also make it accessible and something that you can work collaboratively no matter where you're located in the world. So as we focus on this conversation about a global data environment, what we really want to talk about is those users anywhere, that our customers have really been grappling with the problem of 2 or 3 years ago, their human beings, along with the applications that they were using, were located very close to their data, often in a corporate headquarters data center, at least in proximity where they could be on low latency networks. And over the last few years, those humans and their applications have moved. This comes on the tail of the move to the cloud, where data became decentralized, that a data set no longer was distributed across maybe 2 or 3 types of storage in a data center, high performance flash, low cost object, some sort of scale out NAS. Now that data is also being spread across different clouds, different cloud regions. So this concept of how you make a user who's a data-driven user able to work effectively, be productive with low latency so they can get their work done, whether they're working on data science, they're working on genomic sequences, they're doing some kind of video processing. Making those folks productive is a big component of what is making a global data environment so interesting today. So let me just kind of walk through how this works. The concept of a global data environment is we have created metadata about the data that already exists. So let's say we're sitting in in a data center in New York and have 2 or 3 NAS systems, maybe from different vendors, an object storage system, and a really high performance flash system. When Hammerspace is brought in, the first thing that we do is we do data assimilation to create metadata about all of those environments. Users are connected to the Hammerspace namespace, so all of the users are connected to Hammerspace and can see all of the data that exists across those different storage systems. Not only they can see it, but they can access it, they can have shared read-write with that data, so it kind of breaks down the storage silos. But think now towards the world where those users have now moved. Maybe those users moved towards the beach, away from the cold weather, and are sitting in Los Angeles today. The way we spin up a new data center is first Hammerspace is spun up in the cloud, and we would pick a cloud region that is local to where the users are now in proximity to. So in Los Angeles, there's quite a few options. There's multiple cloud regions sitting in that area. We could select one or multiple of those depending on the organizations and requirements. We would make a copy of that metadata so that the exact same synchronous metadata is what the LA users are interacting with as the New York users. So as changes are made to the file system or the files in New York, Los Angeles will see those changes. As Los Angeles is making changes, New York will see those changes. Pretty straightforward from actually seeing which data is available. And that's not that hard to build. Synchronizing metadata, of course, is complicated, but from a implementation perspective, the metadata is very small. Making multiple copies or having multiple having the metadata sit in those different locations is not storage intensive, it's not network intensive. What is storage and network intensive is the move of the data. So what Hammerspace does is a file granular replication of the data when the users actually need the data. So kind of thinking back to when we first set up Los Angeles, they're interacting with metadata, and we haven't necessarily moved any actual data to Los Angeles until it's needed. We've been using the concept of just-in-time data movement, but even really you could think of that more as ahead-of-time data movement. So what I mean by that is in an environment where we're integrated with the workflow manager, maybe it's the pipeline manager for a genome environment, or it's the workflow manager for a visual effects environment. If we start to access one of those files and know that a data set's going to be needed, we can start to populate only the files that are necessary locally into the cloud region that's accessible there to the Los Angeles users. So how are they interacting with it? They use some sort of remote desktop application. They're interacting with the Hammerspace namespace, and that's the exact same global data environment that their peers in New York are interacting with. As you continue to scale, whether it's because your humans are choosing to live more remotely, or if you have corporate expansion into other countries, if you do an acquisition and want to bring an entire another company into this global data environment, that same process is repeated over and over again as you start to add additional geographies into this global data environment. So that's kind of how the data works from a remote user perspective as they're starting to want to gain access to the global data environment. And then there's also that reverse process of maybe you've done an acquisition and you want to bring more data into the data environment. Many of our users have adopted Hammerspace first for the data orchestration across locations, and then to be able to make that data locally accessible to their users. But maybe they didn't purchase us initially just to replace a NAS environment or a data center environment that exists today. If down the road that opportunity comes up, that data assimilation can be done into the global data environment at any point. So if you want to add additional storage systems, additional data, that assimilation of the data can be done locally, wherever that data exists. And the metadata, again, is updated across all sites so everyone can see all of that data. So you think about, and many of you who are the delegates here have managed IT infrastructures in the past, the concept of Los Angeles being able to see and use all of the data in a secure data center in a NAS environment in London, that's not trivial. And the value of now that data has been raised above the storage system so that data-driven initiatives have more data, that data-driven users have the ability to work collaboratively, even if they're not staying together. It really changes the way business is being done. And so when we think about the business benefits of a global data environment to enable this remote use, the remote workforce, and the decentralization of organizations in general, effectively what we're providing is that scale to provide access to billions of files, hundreds of buckets of data to remote users, regardless of the location of the data or the user. So, Tony Asaro in one of our other videos talked about the concept of performance is being redefined, in that performance of data local in the data center, how fast you can stream a storage system is important, but how fast you can add performance to a remote user is very important. The concept of scale is also changing, that it's not just about how many nodes or how many billions of files can you fit in a single storage system. It's how many geographies, how many types of storage can you span, how many cloud services can you make this data available to make it all about the data and not the storage system decision in and of itself. Simplicity is huge, that now you have your users and your applications connected to the global data environment, and that's where IT has to connect them and ensure a secure connection. Below that, if data systems are being added or end-of-lifed, if new data sets are being connected, you don't have to figure out how to make that data accessible to the users who need it. It's integrated into the metadata of the global data environment and instantly accessible if you've given them the permissions to see it. So the simplicity of managing this environment, the simplicity of not having to have tickets opened by IT or to IT to make data sets move, because that's done through automated data orchestration, really simplifies the entire environment that has been built since kind of the advent of the cloud started and data started to get decentralized. And then lastly, thinking about accessing a larger talent pool, IT resources and cloud resources, development resources are very hard to find. And we all are struggling with that in pretty much any type of organization of how to attract talent. Being able to make a developer, for example, very productive sitting in his home country, or make an animator effective with her own tools in her preferred location. All of these things are really important to being able to attract talent and to be able to hire them so that they can actually be productive in the type of work they do. Some of our customers have said that's the number one reason that they bought Hammerspace, was because without us, they couldn't take on more projects because they had tapped out the talent pool in their cities. So this is a really big benefit that will help businesses not just monetize data, but continue to grow and take on more projects as well.
I mean, I would kind of like to see how you structure your policies and how you visually manage this. When you've given nice descriptions, but seeing a screen of how what the management actually looks like would be kind of interesting.
So I asked Johan to see if he could bring some screenshots up to show you that. But I will tell you this, is that we can do it through our GUI, but everything is also API driven. So we actually have worked with customers to script a lot of it as well, and also integrate it into different applications. So you have multiple ways to do it. But yes, we certainly have GUI driven ways to do it as well.
Right. But I mean, it's even if it's API driven, it sounds like when you're talking about a global file system with potentially lots of different sites, you need some way of actually visualizing this. Whether you control it visually or not, you can't just say, here are all the API commands I use to create this space, and now you need to read through the API commands to figure out what the space looks like.
Very true. That's very true.
Yeah, so we have, these are great questions. So there are three ways you can apply the objectives, and I'm certainly happy to bring up a GUI if that's appropriate. But just as a quick overview, they can be deployed through the GUI, through simple checkboxes. You can also customize declarative objectives in the GUI. You can create both tiers, which dictate placement, as well as what to do with that particular tier. They can be created through command lines, and finally through what we call the Hammerspace Toolkit, HSTK, and you'll find that on GitHub under Hammer-Space. I'm also happy to show you. That has plenty of examples. And HSTK is simply just a Python tool. You can even run locally on Mac or Linux or Windows or pretty much anything. That shows.
Johan, if I may interrupt. So that is a good point. We do give a lot of examples of how to use the scripts and the APIs. However, Johan, if you can just show some of the objectives via the GUI, whether it's something that you've already image that you captured.
Sure.
That would be. I think that's what we're asking is a visualization of it versus just talking about it.
Absolutely,
we've done plenty of that.
So, in the meantime, Molly, you had said that some companies adopt Hammerspace for the data orchestration alone without the data assimilation. I'm trying to understand how that works.
Oh, no, I wasn't saying that, but they're adopting us for, you have to assimilate the data.
So it is assimilation and orchestration, but they really wanted the orchestration part of it is what they really want.
Exactly. Yeah, just to give you some like really direct examples, like they're totally happy with their storage environment, whoever their NAS is or whatever it is. But now they need to orchestrate and they want to use S3 as the tool. The cloud object is the tool from a storage perspective to do that. And they want us to manage that orchestration so that they can actually use S3 in that sort of way.
I got it. All right.
I'll modify that answer just slightly in that you don't have to do data assimilation with us. It could be part of a greenfield opportunity, but there are some customers that may not want to do the data assimilation, but you can use standard tools just like any other NAS solution to get data to us, like using rsync and things of that nature. By and large, our customers do use the data assimilation, I would say in probably 90% of the cases, but there are some cases that they don't want to do that. So they use standard methods of doing migration as well.
All right, so great question. Quick overview. This is just the dashboard where it first meets the eye when you log in. But I think to answer, and I think it was Andy, correct me if I'm wrong, who asked that question, how do you work with objectives? So you'll see here under infrastructure and data, which is essentially is the tab where you do all kind of storage management. You add the storage systems, volumes, configure, shares, and objectives. Objectives can actually be configured from a number of different places. You can even do it when you create a new share. And they apply to anything from share down to a file, or MIME types, or by a descriptor or tag in metadata that you then can assign.
You're telling me here, could you show an objective?
Yes, sir.
Thanks.
So this is showing it from a share level, right? So for example, access-based enumeration and AV scanning through ICAP, worm operation. And you can do a number of different things. So you can completely control availability, durability, and you can do things such as deny create, deny open. You can be incredibly granular. So it goes far beyond even worm. You can also say things such as exclude this particular data from this storage system all the way down to a bucket or a volume. If I decide to keep it online, that means that there will always be a live copy of that particular data set on this location or this site. And I can control things through A time, C time, M time, slice and dice things. And here I determine that for this data, I always want it on, for example, this S3 bucket or on this NetApp.
And let's keep in mind too, and correct me if I'm wrong, Johan. So for example, you might want to create a delete deny on your share, for example, so that somebody can't come in and delete your data and do it that way. And this is happening at the share level. We also can do that at the file level.
Correct.
But each one of these policies then are for that local Hammerspace. It does not go throughout all of the other sites. Each site can control their own set of objectives within their environment, because somebody in New York may have a different set of rules of how they want to treat their data than somebody in Tokyo does, for example.
And you know, a key point too, and that's, thank you. A key point too is that we can further refine the value of a snapshot, for example, by applying what we call undelete, which gives it a wide dispersal of essentially a network-wide trash bin or recycle bin, depending on which OS you're on. We can also implement file versioning, and file versioning in this case is not time-based like snapshots, but event-based. So it's based on real changes in the file system itself. And again, these can be these are the applied, and also shows the active objectives. And we can go down further in this to apply this on individual files. But I can go into, you know, subdirectories file and whatnot.